Okay, welcome back. Today again is we'll do the quiz, answer some questions, and then it's all about implicitly defined functions. So let's go jump to the quiz. All right, so let's take a look. We have part A, and that is let f of x equal 4x plus cosine of 3x. Find the derivative of the inverse function of x, evaluated at x equal 1. So this is pretty much a step-by-step process because we have a formula. Let me remind you of the formula, because without that, you have no chance. So don't forget that the derivative of f inverse of x is equal to 1 over f prime of f inverse. Interesting. Of x. Okay, so that was a big formula that we had a couple days ago, and it was really the only formula, so you definitely need to know it. So pretty much looking at this, we need to find f prime. We need to find f inverse of the value, and then we have to plug in. So those are kind of the steps that we're going to do. So let's first find f prime. Let me just recopy f. And let's find f prime. And that's not supposed to be very hard. So if f of x is 4x plus cosine of 3x, f prime of x, what's the derivative of 4x?
4.
Yeah, 4. And what rule do we have to use to find the derivative of the cosine of 3x?
Chain rule.
Yep, chain rule. Derivative of 3x is 3. And the derivative of cosine is negative sine. So this becomes a negative. Set this aside on me. But so it becomes negative 3 sine of 3x. Any questions on how to find f prime first? Okay, now we need to find what is f inverse of 1. And the promise that I gave you is that I'll only give you nice numbers. So we need to find a value, because the inverse means go backwards. We need to find a value x that gives you 1 when you plug in. And what value of x will give you 1 when you plug in? Yeah, 0. Okay, so now notice f inverse of 0 or f inverse of 0 equals, sorry, f inverse of 1 equals 0. That's better. So now what we need to do is plug in. So this is not supposed to be too hard. What is f prime of 0? So that x becomes a 0. And what do you get when you plug in? Yeah, you get 4. Because it's 4 minus 3 times sine of 0. Sine of 0 is 0, so it's 4 minus 0. And that's just 4. Any questions at all on that? Okay, now we just drop it into the formula. Let's rewrite the formula. So I'm going to drop it into the formula. And this gives me a 1 over f prime of f inverse of 1. And that will just be 1 over 4. Are there any questions on part A? Any questions? Okay, so for part B, we want to find the derivative of the arctangent of x times the arcsine of x. Okay, so let's copy and paste it. All right, so here's our function, and we want to find its derivative. What rule do we have to use to find the derivative of the arctangent of x times the arcsine of x? So what's the rule?
Product.
Yep, there's a product rule, right? Because it's a multiplication of two functions. So what I'm going to do, this is easier. I'm going to copy it and paste it twice. And then I'm going to adjust, because the product rule says that you leave the second one alone, take the derivative of the first, leave the first one alone, and take the derivative of the second. So now you're supposed to just remember, what is the derivative of the inverse tangent of x? It's
1 over 1 plus x squared.
Yeah, so it's 1 over 1 plus x squared. So it just becomes 1 plus x squared on the bottom. Inverse tangent goes away. And that's the first piece. Anyone lost on what I just did? Okay, then it says we take the function tan inverse of x times the derivative of g of x, or the derivative of the sine inverse of x. Well, what is the derivative of the inverse sine of x?
One over the square root of 1 minus x squared.
Exactly. So we have 1 over, I'm going to put it down at the bottom, the square root of 1 minus x squared. Get rid of the inverse sign, because I got it. And that's the derivative. So let's go f prime of x equals. Again, I don't think there's really any work to show, but I can definitely spend time explaining it. Are there any questions? Are there any questions on figuring out the derivative of this inverse sine of tangent of x times the inverse sine of x? Any questions? Okay, so as you can see, if you don't remember your derivative rules, it's over for you. So you have to have those down. Product rule, chain rule, quotient rule. They just keep coming and they're not going away. Okay, they won't go away at all. Basically, not just this quarter, but they won't go away until you're done taking math. Okay, they're going to keep coming at you. So just let you know, you need to get these down in your head. And similarly, you definitely need to know the derivative of the inverse sine, the inverse tangent, and the inverse secant. Because if you don't, you certainly don't want to have to derive it all. That's a pain. So you want to have it memorized. Okay, and next quarter it's going to come up a lot because you have to memorize it backwards. Any questions at all? Okay, so if there's no questions, are there any questions about anything else? Any questions? Give you a moment to think about it.
My morning confessional, the mathematics confessional here. I totally got the first problem right the first time, and then second guessed myself and did it wrong.
Did you show your work so I got to see the right part?
Not sufficiently.
Because if you show your work and you get it wrong, but then and you get it right, and then you like say, no, this was a mistake, and then you do something wrong, you'll still get most of the points. Just let you know.
Yeah, no, I just went back and like changed the values.
Yeah, so that could get you. because I can't see anything you erased or changed. I can only see things that are there. Does that make sense? Okay, and that's just a good rule of thumb for especially tests where it matters, is that I believe in never using an eraser. You're much better off like lightly crossing something out, because you'll never get points taken off for crossing something out, but you can get points for crossing something out that was right if I can still see it. Okay, and that's not just me. Pretty much all math instructors do that. Okay, yeah, so careful at second guessing. Any other questions? Okay, if there's no questions, I think we can talk about implicitly defined functions. Okay, so first thing is that you've learned about, you know what a function is. And a function means that given a number, okay, you get a number out in this class. By the way, I would say given an item, you get an item out is a better word. But for this class, we can get away with numbers. Okay, that changes, by the way, if you take third quarter calculus. But we're good for this class. So given a number, you get a number out, and you're used to seeing it as like f of x. So let me write down explicitly first. Defined function looks like y equals f of x. That's basically an explicitly defined function of a single variable where you get a single number out. Okay, and that could be y equals, I don't know, 3 plus x. It could be y equals sine of x plus 7. Those are all explicitly defined functions. It means you can write down y on the left-hand side. And on the right-hand side, you have stuff with x's in it and numbers, okay, and functions and stuff. But that's explicitly defined. Turns out not all functions can even be defined explicitly. So let me give you an example, and then we'll define it, of an implicitly defined function. And that would be something like xy minus the sine, I lost it, there we go, the sine of x plus the cosine of y equals xy squared. All right, you look at that and you say, well, could you write that as y equals f of x? What do you think? If I gave you an hour, could you write that as y equals f of x? Do you think? You think you have the ability to do that right now? You can be honest.
No.
All right, I see one yes. All right, Rigby, I'll give you an hour. I've challenged you. The answer is no. Could I do it? Yes. Using third quarter mathematics, and at the end of third quarter, you won't be able to do it. It's brutal. Even after knowing the mathematics behind it, you won't be able to do it. It would be, this is something that we don't know, you just don't know how to solve. Even with 5 hours of explaining, I don't think I can explain, I don't think you would understand why it works. The point is that there is no nice algebra you could do on this to get y equals something, okay, with no other y's on the right-hand side. Okay, and that's what, and so you have an implicitly defined function, but you can't write it as an explicitly defined function because the algebra is too hard. Okay, or maybe you're lazy. In this case, the algebra is too hard. Sometimes it's just laziness. And laziness is okay sometimes too. Okay, so this is an example of an implicitly defined function, but if we said, let's suppose that x equals, I don't know, pi over 3, then do you think you could get y using a calculator, for example? And maybe I'll restrict the domain to, 0 to pi or something like that. Do you think you could find y using a calculator or a computer if I gave you a value for x? What do you think? At least approximate. I don't see anyone jumping in. Are you listening? So if I gave you a value of x, do you think with computer capability, do you think you can find a y? Oh, the y. Yeah, the answer is yes, yes. You could pop into Desmos, for example, look at the graph, and then put your cursor near the graph, and it'll give you the x and y. Does that make sense? So that's a computer way of doing it. Okay, and there's other computer ways of doing it. Is there a way without the computer to get a good approximation of y? The answer is yes, but you don't know how yet. But you're going to learn in a few weeks. Okay, I don't remember the day we do it, but we'll learn how to do it. It's called Newton's method. So there actually is a way to do it. So this is a function as long as you restrict the domain. This is a function, but we can't explicitly write it. So this is an implicitly defined function. I'll give you another one. How about 2x minus y equals 0? Is that an implicitly defined function? What do you think? Yeah, it is. Okay, because I'm looking at it, and it's certainly not explicit because it doesn't say y equals a function of x. It says 2x minus y equals 0. Okay, could you figure out how to create it, how to change it and make it explicitly defined? Yeah, if you don't, then you don't belong in this class, right? Okay, so just because you can make it explicitly defined doesn't mean it is explicitly defined. Got it? Okay, the first one I gave you can't, okay? But the second one, you better know how to solve for y. Okay, so these are both examples of implicitly defined functions. Any questions on that? All right, now we're going to go back to that one question that I asked, which you all thought it was a line, as in the first word, first math word that you learned, a shape of a graph as a baby, and it's not a line. It is a circle. Okay. If any of you have kids, you've heard them say it's always cute. Circle. They say it in a real cute way. But they say that before they say line. And the circle is important. And that's why I want to pop it in here, especially important for today. So we have a circle. And if hopefully you remember, maybe you can pop in the chat box, what is the geometry of the derivative in a few words? What is the geometry of the derivative? We did this in the first week of class. A couple of easy words. Yeah, it's the slope of something. Yeah, slope of the tangent line. So it's the slope of the tangent line. So I want to pop in the circles. First thing, by the way, the circle is not the graph of a function as it is because it doesn't pass the vertical line test, right? But if you restrict the domain, okay, then it is a graph of a function, okay? if you just make sure that you only look at the top half, for example. Okay, if you restrict the domain and the range, then if you restrict the domain and range, you get the graph of a function. And in particular, at any point on the circle, does the slope exist? Is there a derivative? And I've got one in particular. So there's an example where I've got a point on the circle. There's a clear tangent line, and it has a derivative. In fact, the derivative is -1. Does every point on the circle have a derivative? What do you think? Okay, it's a tough little question. Okay, I didn't expect you guys to see the problem, but as soon as I put my cursor in the right spot, what's the problem with that point right there? What is the slope of the tangent line at that point? There is a tangent line, but does it have a slope? Okay, so hopefully you can look at that point and see that you have a vertical tangent line. And hopefully you remember from your, I don't know, 8th grade math that vertical lines don't have slopes. Because if you try to do the rise over run, you have a 0 in the denominator and you got bad things going on. So one issue, by the way, is that you don't always get, even though it's like a beautiful smooth curve, there's nothing smoother than a circle. That does not mean that the derivative is defined everywhere. It turns out it's defined everywhere except here and here. Okay, that's the other point. It's not defined. But everywhere else, you can draw a tangent line, you can look at the slope, and it does have a nice slope or a slope, and you can write it down, and you can talk about the derivative of this implicitly defined function, and in particular, the function, the unit circle, hopefully you all remember, has equation x squared plus y squared is 1. Does that ring a bell, I hope?
Yes.
Okay. Now, can you solve this? Can you solve this for y? Let's do the top circle so you don't have to worry about plus or minuses. Can you do it?
Yes.
Yeah, you can. But when you do, you're going to have square roots and squares inside. It's just going to be messy. On the other hand, the equation x squared plus y squared is 1 is a beautiful polynomial, like simple polynomial. So it's actually, life is a lot easier if you don't solve it, if we want to talk about the derivative. Any questions on that idea? Okay, so this is an example where you can actually solve, but solving actually makes it messy. And if you want to avoid messiness, then we want to find a better way of finding the derivative than solving and then kind of using some messy chain rule stuff. Any questions on that idea?
Yeah, I have a question. What about when the line is horizontal? Is that the same? Does that apply the same as?
So right there, for example,
Yeah.
okay, that has a derivative. What's the slope of a horizontal line? Not 1.
0.
0. Slope of a horizontal line is 0. And 0 is a beautiful number, right? It's one of the easiest numbers in the world. So there's no problem. Do you see?
Okay, so it's only the 2 points.
Right. Vertical's bad because dividing by 0 is not wonderful. Do you see?
Yeah, I got it. Thanks.
Yeah, 0 divided by number is no problem, but a number divided by 0 is a problem. And that's what's going on here. Okay, is that clear? Okay, and kind of the main takeaway here is that even though we have a function that is implicitly defined, we could still look at it and say, yeah, almost everywhere there's a slope of a tangent line, there's a derivative. And we want to find that derivative. Any questions on that? All right, so what we're going to do now is figure out how to find the derivatives. And the idea, and I think I'm going to do it by the example I just showed you, is we're going to start out with x squared plus y squared equals 1. And what I don't want to do, I don't want to solve for y, because that's messy. Instead, I want to find the derivative implicitly. And I'm going to do the next step even though you don't need to, but it'll help you understand it when you're first seeing it. So the idea here is that we have x squared plus, now y is a function of x. We can solve, okay? We could solve for y in terms of x. And if we're on the upper semicircle, up, then it would be what, the square root of 1 minus x squared. But the point is I don't want to write the square root of 1 minus x squared. I want to say it's a function of x. So we could just call this f of x. And it's f of x squared. This is the procrastinating away the solving equals 1. Any questions on that? Okay, the next step is what I like to call the golden rule of mathematics. Have you heard of this before? What's the golden rule of mathematics? What's the golden rule of life? That's something you should have heard. Opening up because it's really important for doing this. Let's see y'all jumping in. Okay, treat equations how you would like them to treat you, okay? Or you can think of yourself as the left-hand side, and then the others as the right-hand side. And that's do unto the left as thou wast do unto the right. Does that make sense? So in particular, what we're going to do, because we want to find a derivative, is we're going to take a derivative. And if you have something equals something and you take a derivative of both sides, then it still should be true. So that's going to be the big step, is we're going to take a derivative of both sides of the equation. So I get d over dx of the left-hand side equals d over dx of the right-hand side. Any questions on that? Okay, this is called implicit differentiation, by the way, if you want to know a word for it, but I'll write it down in a bit. So this is implicit differentiation. And let's do the easy one first. You better all know what the derivative of 1 is.
0.
Yeah, 0. Okay. So again, I'm going to copy and paste. And let's do the right-hand side first. That's 0. Now let's do the left-hand side. What's the derivative of x squared with respect to x? Yeah, 2x. Okay, so what I can do is I can take the derivative now. And the x squared becomes a 2x. Okay, now what rule do I have to use to find the derivative of f of x quantity squared? What's the big rule? Chain rule. So what is the derivative of f of x? Well, if we knew what the derivative of f of x was, we wouldn't have to do anything because that's what our question is. But what we can at least do is we can write it down as f prime of x. Do I know it? I don't know it, but I know the symbol for it. And then what's the derivative of something squared? It's 2 times the something. Any questions on that? Okay. The next thing I'm going to do, just for a little simplicity, is f of x is y, and f prime of x is y prime. So I'm just going to rewrite it that way. Anyone lost on what I've done so far? Okay, what's my goal? What am I trying to get? Right, what am I trying to find? What's the whole goal in this entire class? Don't just say passing it. So what is the goal? Yeah, I want to find the derivative. I'm going to find y prime. But the good news is that's easy. We just have 2x plus 2y prime equals 0. Now this is basic algebra. I subtract 2x from both sides. Maybe I'll just do I'll show you the algebra steps. 2y prime equals negative 2x. And then I just divide by 2y. And I get y prime equals, and the 2's cancel, and I just get negative x over y. Any questions on that? Any questions? Okay, notice that I started with an implicitly defined function. I never solved for y. I didn't need to. But when I'm done, my derivative is implicitly defined also because it has a y in it, which is often fine. Okay. The interesting thing is there's a poor choice of words in these things in mathematics. Maybe because they came up with the words before the new calculus. But we have negative x over y. And you think about this, the slope of the tangent line, right? What's the tangent, by the way, in terms of x and y? Anyone know? You should know. Might help to look at Desmos again. If we have a point, remember that the x coordinate was the cosine and the y coordinate is the sine. So what is a tangent? You're all supposed to know this one. In terms of x and y. Sine over cosine. So in terms of x and y, what is it? Remember the x coordinate is a cosine, the y coordinate is a sine. Well, sine is y, cosine is x. So sine over cosine is y over x. So the tangent at a point on the unit circle, okay, is just y over x. Unfortunately, the slope of the tangent line is negative x over y. So someone screwed up with language. So sorry about that, but don't shoot the messenger in this one. All right, so the idea is we can now find out. So for example, find the slope of the tangent line to the unit circle at the point one half comma square root of 3 over 2. And that should be easy now. So what's the slope of the tangent line to the unit circle at the point 1/2 square root of 3 over 2? And what do you get? The answer is you've done all the work, so now you just have to look at it. I don't see y'all jumping in. This isn't supposed to be hard. Maybe I'll highlight that. Yeah. I'm going to do a little simplification because it's prettier. But the idea is we just take this equation, y prime equals negative x over y. So we have y prime equals negative x over y. X is 1/2. Y is root 3 over 2. And it just wants to be simplified. This is just equal to negative 1 over root 3. You don't have to, but it's a lot prettier that way. Any questions at all on that? And do you see how easy that was? Okay, whereas if we did it explicitly, this would be a lot more work. Just let you know that. But we have this beautiful formula, negative x over y, and you just plug in. Okay, I want to highlight a few things. I want to mention things that I'm not going to do because you don't need to. First thing is I'm not going to write it. I'm not going to turn the y into f of x. I think it's fine to just keep it as y. I only did that to highlight the fact that we're using the chain rule. So you just got to remember that if we want to take a derivative with respect to x and we have a y, you better use a chain rule. So let me do an example. Find dy dx. At the point two comma 1. If, and now let's write down an implicitly defined equation. If x cubed plus 3y squared minus y. Let's make that a 2y cubed actually. Just to highlight something. Y squared plus x minus y equals, and I better work this out, 10. Just had to make sure it worked. All right. Now, there are two ways of doing it. One is solve for y first and then find the derivative. Do you think that is a nice way of doing it? What do you think? So you got to get y by itself with all the x's on the right-hand side. What do you think? Is that the best? Is that the best way of doing it? It can be done. Probably not by you, but it can be done. Yeah, some hours later. My guess is even hours wouldn't help you. Maybe with the internet, maybe, but without the internet, I don't think you can do this. You all hopefully remember the quadratic formula, but this is a cubic. How many of you remember the cubic formula? The answer is none of you. It's miserable. Goes for like a page long. Okay, so we're not going to do that. You don't want to solve for y in terms of x. It would be miserable. Okay, this could be done, but it would be miserable. Okay, unlike the circle where you actually could do it and it would be a pain. This would be completely miserable, more than a pain. On the other hand, we can implicitly differentiate. So now I'm going to do that. And unlike the last one, I'm not going to show every little tiny step. I'm just going to talk my way through it. So what I need to do is I need to take a derivative of both sides. So I'm just going to take a derivative of every term. Let's start out with x cubed. What's d over dx of x cubed? Shouldn't be hard.
3x squared.
Yeah, it's 3x squared. Plus. Okay, now we need to do d over dx of 2y cubed. So let me give you kind of a nice rule of thumb that's going to help you out. If it's y instead of x, it means you have to use a chain rule. So it just means at the end, you got to multiply by y prime. Okay, which is basically what I did before. I just did it with all the symbols. So we first just take a regular derivative, and that's going to be 2 times 3y squared, or 6y squared. But then you got to use a chain rule, and you got to multiply by y prime. Have I lost anyone there? Any questions on that? Okay, similarly, we're going to have a minus y squared. The derivative of y squared is 2y, but it's respect to x, so it's times y prime. So we have minus 2y, y prime. Any questions on that? Then we take the derivative of x. Now we're in the right variable again. That's just plus 1. And then we have the derivative of y, and that's just y prime. And then we have the derivative of 10, and that's 0. So I want to stop for a moment. Any questions on this? Any questions? All right, so now I'm going to give you a piece of advice. There are a few things we can do now. One is we can solve for y prime and plug in. But there's a better way, an easier way. And what's the easier way of doing this? What's easier than solving for y prime and then plugging in? Any thoughts? Give you a minute. We definitely don't need to solve for x. That's not going to do anything for us, actually. It's going to make a mess, actually, because we don't want x. Okay, the answer is, instead of solving for y prime and then plugging in, it's a lot easier to plug in and then solve for y prime. So that's what I'm going to do next. I'm just going to plug in x is 2 and y is 1. And I could do that right away. So let's plug in. If you plug in 2, you get 3 times 2 squared. That's 12. And then we have plus. And then we have 6 times y squared. That's 6 times 1, which is 6. Y prime. And then we have minus 2 times y, which is just 2. Y prime. And then we have plus 1 minus y prime equals 0. Okay, and by the way, if you solve for y prime and then plugged in, you can still get it. It's just going to take a lot longer. Because now we can just combine like terms. So let's do that. We have 12 plus 1 is 13. Plus, we have 6y prime minus 2y prime minus y prime, which is 3y prime. Equals 0. Any questions so far? And then I just subtract 13 and divide by 3. And I get y prime is equal to negative 13 over 3. And I'm done. Do you agree that was pretty easy? Okay. If you had solved for y prime first, it's just messy because you got to move all those x squareds and y squareds, and then you plug in. It's just going to be a mess. Whereas this is much easier. So if you have the values of x and y, use them as soon as you take the derivative. Okay, what's wrong with plugging in at the very first step right here? What's wrong with plugging in 2, 1 at that point? Yeah, it's not the derivative, but even worse, you're just going to get 10 equals 10. Then what are you going to do? You're never going to find a derivative. So you have to take the derivative before you plug in. Any questions on this example? Okay, let me give you the next example. They're getting harder. And I'm just going to copy and paste. Maybe I'll change the numbers around a bit. How about a negative 1, 1? If. Now let's do an equation. X squared times y plus xy cubed minus y over x plus y minus 3x equals, and now I just have to do in my head quickly, 1, 0, 1, 2, 5. Just want to make sure it works. All right. So now it's the same first step. We're going to take the derivative of both sides. So we're going to take the derivative of every term individually. And I want to start out with the x squared y. Why is this one a little different than what we've already done? What do we have to do on this one to find the derivative of x squared y?
Do we have to use the product rule and the chain rule?
Yes, exactly. We're going to need the product rule and we're going to need the chain rule. So let's do the product rule. And that says take the derivative of x squared, which is 2x, times the second, which is just y, and then plus x squared times the derivative of y, and that's y prime. Okay, it's times 1 times y prime. That's a chain rule. And then plus. Okay, similarly with xy cubed, we have to use the product rule and the chain rule. So the derivative of x is 1 times y cubed plus, and then we're going to have x times the derivative of y cubed. Well, the derivative of y cubed is 3y squared. But we got to use a chain rule and multiply by y prime. So I want to stop. Any questions on how I came up with that so far? Minus. Okay, what about y over x? What do we have to do? To find the derivative of y over x with respect to x. Yeah, we use a quotient rule. So now we're going to do low, which is x, times d high, which is y prime, and then minus, and then we're going to have, so it's high d low, and that's going to be y times the derivative of x, which is 1, square the bottom, and away you go. Okay, then plus, derivative of y is just y prime, and then minus, derivative of 3x is 3, equals, derivative of 5 is 0. Any questions at all on this example so far? All right, what's the next step?
Plug in.
Plug in, okay? Don't even think about solving for y prime first. I mean, it's just a mess. Instead, I plug in and it's gonna have a bunch of numbers and some y primes. So we have 2 times x times y, that's -2. Then we have plus x squared, which is 1 times y prime, so plus y prime. And then plus y cubed, which is just 1. And then plus 3xy squared, which is a -3 y prime. And then we have a minus, and we have a fraction. We have xy prime, which is negative y prime, and then minus 1, because y is 1, over 1, which is nice because that's just going to go away, the over 1. Then we have plus y prime minus 3 equals 0. Any questions on this so far? Any questions? Okay, now we got to simplify. So let's simplify as much as we can. So we have a -2 plus 1 minus 3. So -2 plus 1 minus 3 is -4. And then we have a y prime minus 3y prime, that's -2y prime. And then minus a minus y prime. And what do you get? We have -2y prime plus y prime. And then we have a plus y prime. So how many y primes do we have? None. So we get -4 equals 0. I wanted to give you an example like this. What does that tell you? Yeah, D&E. And sometimes derivatives don't exist, and this is an example. Any questions on the example where it does not exist? Okay, any questions? Okay, get lots of examples. These come up a lot, especially when you're dealing with things like functions where you know relationships between x and y, but you don't know one in terms of the other. Okay, and that does happen a lot. All right, easy enough? Okay, so just to let you know where we are, the next thing is tangent lines. Okay, and that's really no big deal. So let me just do an example. Find the equation of the tangent line to xy squared plus x minus 3y equals, and let's do one. -1. Hopefully I did my arithmetic right. At the point 1, 2. Any questions on the question? Okay, what do we need to find? Yeah, we need to find the first derivative because the first derivative is the slope of the tangent line. We have a point, and if you have a point and a slope, then you know how to find the equation. So let's do it. I'm going to take the derivative of both sides. So I'm going to use a product rule. So we take the derivative of x, which is 1 times y squared, and then plus, and then we're going to have a 2xy prime, because we have x times the derivative of y squared. Derivative of y squared is 2y times the y prime because of the chain rule. Putting it together gives you the 2xy prime. Okay, then minus 3y prime equals 0. Then we go ahead and plug in. And again, what we've got is we got the 0.12. So let's plug in. So we get 4 plus, so again, x is 1, y is 2. So that gives you 4y prime. And then minus 3y prime equals 0. And all of a sudden, things are looking really pretty. What's 4y prime minus 3y prime?
Y
Yeah, it's just 4 plus y prime equals 0. So what is the derivative?
-4.
Negative. Good. Derivative is -4. And now we just finish it off because the question was find the equation of the tangent line. Well, that's easy. So how do we get the equation of the tangent line? we just go ahead and use the point slope formula. And we can say that y minus 2, because the y coordinate is 2, equals m, which is negative 4. And then we have x minus 1. And we don't have to, but I think I'm just going to make it pretty. Y equals, so we get negative 4x. And then we have a plus 6. Just doing the basic algebra. Okay. If you left it like this, that's fine, by the way. Okay. As long as there's no primes left, you're good. Any questions? Any questions on finding the equation of a tangent line? Okay, it's really not that hard. Okay. What I haven't done yet, and I probably should do one example of, is when you don't have a point. So let's suppose. So let's suppose that we have y sine of x plus y squared minus xy equals 0. Find dy dx. All right. Well, what do we do? Going to have to take the derivative of each term. Yeah, of both sides. So product rule for the first one. So let's do it. Derivative of the first is just y prime, so you get sine of x times y prime. I usually like to write my y primes on the right-hand side. It's a good idea. And then plus 2y, y prime. And then, oh, sorry, I forgot to do the plus the y times the derivative of the sine of x, which is cosine of x. And we add the 2y, y prime. And then we're going to have product rule again. The minus derivative of x is 1. So it's just y. And then a minus. And then then x times the derivative of y, which is y prime. And then equals 0. Any questions? Okay, this is an example where we can't plug in. Why not? All the other examples I plugged in at this point. So why can't we plug in now?
We don't have a point.
Yeah, we don't have anything to plug in. So we can't do that. So we're forced to solve for y prime. So what I'm going to do is I'm going to take, remember, I'm going to think about everything that isn't y prime like a number. So I need to put the non-y prime stuff to the right and combine the like terms of y primes on the left. So on the y prime terms are going to be sine of x sine of x, and then we're going to have a plus 2y. And then we're going to have a minus x times y prime equals, and then we got to bring the other stuff over, and we get a y minus y cosine x. Any questions on that step? Okay, what do I need to do next? So what's next? Yeah, now we divide. So we get y prime equals, and we're gonna have a fraction. We have y minus y cosine of x on the numerator, and the denominator will be sine of x plus 2y minus x. All right, notice that we have the derivative of y implicitly because there's x's and y's on the right-hand side. Okay, by the way, if I asked you to do it explicitly, could you?
Yes.
Yes? Okay, well, if you think yes, tell me how. I'd like to learn. How would you explicitly mean you got to get y by itself over here? What algebra would you use to get y by itself? Okay, actually, this one you could do actually, but my guess is you wouldn't want to. Now that I'm looking at it, this one is possible. Okay, but you don't want to do it. How would you do it? In 2 words. And don't say, and the 2 words are not give up, by the way. No? Not hearing y'all jump in? You'd use the quadratic formula because it's a quadratic in y, but it's not pretty at all. The last thing you want to do is do that. So, whereas this isn't too bad as a y prime. Any questions on that? Okay, so now what I want to do is I want to do another example, but I'm going to have a different question, slightly different. We'll start out with let. And let me write down an implicitly defined function. So how about y cubed minus xy plus y squared plus 3y equals 7. Any questions so far? Okay, I'm not going to ask you to find dy dx. That would be too nice. Instead, I want you to find d squared y over dx squared. All right, that is the second derivative. How do you find a second derivative? What's the first step in finding the second derivative?
Find the first derivative.
Exactly. We still have to do what we did before. We find the first derivative. And to find the first derivative, derivative of y cubed will be 3y squared y prime. Any questions? Okay, then I'm going to go minus. Now I use a product rule. Derivative of x is 1 times y. And then minus the derivative of y is y prime. So it's xy prime. And then plus 2y y prime. And then plus 3 equals 0. Any questions on that? Okay, there are a couple choices here. And I'm going to do it the little bit easier way. And that is to now just take another derivative implicitly. So let's do that. So if we want to take another derivative implicitly, we just do that, we take a derivative. So now we got to use the product rule. And we're going to have a 6y, y prime times y prime. Or 6y prime squared. And then we're going to have a plus 3y squared times y double prime. Anyone lost on the product rule there? Okay, then we're going to have a minus y prime. And then we're going to have a minus. Derivative of x is 1, so it's y prime again. Derivative of y prime is y double prime. So minus x, y double prime. Any questions so far? Okay, and then we're going to have the y prime. So we're going to have plus 2 y prime times y prime, which is 2y prime squared. And then plus, because we're in the middle of the product rule, 2y, y double prime. And the 3 goes away, equals 0. And we're getting there. Now what do we have to do? Yeah, solve for y double prime. So I'm going to combine the like terms of y double prime and move everything over to the right, everything else over to the right. So we have a 3y squared for a y double prime, just going through. Then we have a minus x. And then we have a plus 2y. Y double prime equals, and then we're going to have a 6y, y prime squared with a negative. And then we have a, I'm just going to put these together, a plus 2y prime. And then we have a minus 2y prime squared. And that's all of them. So the next step is divide. So what we get is y double prime equals, we have a fraction. The numerator is the right-hand side. And the denominator is this left-hand factor. So I can copy and paste it down if it lets me. Okay, where? And now over here, we need to find out what y prime is. That's why I left space. And hopefully you'll be okay with it. I'm going to do all in one step. So y prime equals, so I'm going to bring over the y and the 3. And that's going to be a y minus 3. And then the coefficient is going to be 3y squared. And minus x plus 2y. So that was my y prime. So that's my y prime. And if you want, maybe I'll do it because it's not too bad. It's not too good either. These get messy as you're seeing. Is everywhere I see a y prime, if it'll let me, what I have, this. That's better. What I have is this y minus 3 over the mess. Yeah, let me do it. Good. So now I just got to take all those y primes, turn them into what we have for y prime. Okay, and yeah, it's very messy. How did I get negative 6y y prime squared? This guy here? So that came from here, and I just subtracted it. Does that make sense? Yeah, so all the things without the y prime, double primes got moved over to the left, which means they're subtracting, changing the signs. And there's a chance I made a mistake somewhere, but no one caught me on it, so maybe I didn't. Because with this kind of work, usually you make some mistake somewhere. And if this were, you know, people's lives depended on it, then you have a whole team of people looking over it to make sure there's no mistakes. All right, and you can see this is quite damn messy, but it is what it is. And there is no way you're going to want to do this or, you know, to do this explicitly, because this y cubed means it is horrible. Okay, and you may think this is horrible. When I mean horrible, I mean that it would take probably 100 pages of typing. And I'm not doing that. Any questions at all on finding a derivative of an implicitly defined function?
Yeah, Larry, I have a question.
Sure.
So we found y double prime first. How did you go back to find just y prime?
Oh, I skipped that step earlier because I wanted to jump to y double prime. I just grabbed this line here
Uh-huh.
and I just solved for y prime.
Oh, yeah. Okay.
Yeah. So literally just algebra. And
Okay.
not pretty algebra, but algebra. Does that make
Gotcha.
sense?
Mm-hmm.
Yeah.
Thank you.
I decided to
Is it-
wait on that. I could have done it right away, but then I thought you might be confused because then you have this and then we don't use this until the end. Do you see? So that's why I waited till the end to do that.
Yeah, thank you.
Okay.
So
we're at-
noticing that the denominator for y prime and for y double prime is the same, is that the sort of thing we can expect generally?
you know, I've never thought about it, but possibly. I didn't think about it for a while. Yeah, it has to do with the fact. See, notice that we have y prime right here. So if you wanted to find y double prime now, you could use the quotient rule. And you're going to get this denominator. Do you see it's squared? So that's the reason why that happened. So if you have a denominator and you take another derivative, you get the same denominator, but squared. And this time it's a denominator squared here. When you square this, there's another one here. Probably things simplify and you lose one. But we're out of time, so I want to stop the recording.